Welcome to another episode of Field Phone Ops. Today's episode we're going to do an intro to basic field phone operational concepts. So sit back and I hope you learned something. My goal is to shed some light on how field phones operate and interface. I cover mainly military field phones, but the principles of operation are the same for military and commercial phones. If I have presented any incorrect information, I apologize. Many of the phones I possess have no manuals, or the manuals are not in English. I hope you gain some knowledge and understanding of how field phones work. I also want to pass on that most field phones, regardless of country of origin, will operate with each other. Quick and brief history of field phones. Military usage of field phones started at the end of the 1800s and the beginning of the 1900s. The first uses were actually to connect military outposts and forts together, and there was extensive use to connect artillery batteries and direction control centers, mainly for coastal defense and harbor defense. During World War I, both sides extensively deployed field phones, most using a single-wire earth-ground system. The post-war years saw extensive development of equipment and procedures for installing, using, and maintaining the systems. By World War II, all the parties involved extensively used field phones. Even with the advent of radio, wired communications were preferred, and all the armies had extensive signal corps and troops who installed wire as close as possible to the front lines. This became difficult as the war was very fast-moving. After World War II, the technology remained fairly stable, with the two-wire ring-down phones being used. During the 1960s, advances in electronics now allowed armies to field automatic telephone exchanges that allowed for dialing. There still was a place for the two-wire field phone, which were often used in forward positions. With the advent of smaller electronics, it was now possible to use radio and satellite links to connect phone calls. It was common in the 1980s to have dial-up phone capability in forward positions, and in the 1990s, digital phones began making their appearance that allowed for cryptographically secured communications that were EMP resistant. Even with all these advancements, two-wire field phones are still in use. They're reliable, robust, easy to install and maintain. Okay, how field phones work. Basically, they work on the principle that a microphone changes the audio into electrical energy using magnetism and carbon granules. This was the premise that Alexander Graham Bell used when he designed his first phone. The electrical energy is placed on wire conductors to a speaker, which then converts it back into sound again, using, once again, magnetism. Since these voltages and current levels are very, very low, you needed to have some way to notify the other end to pick the phone and answer the call. This is where the ringer or the hand crank magnetos were developed to basically ring and send a higher level and powered signal to the other end to cause it to ring a bell. These ringing voltages varied between 70 and 100 and some volts AC, which would light you up. They'll give you a good shock if you come in contact with it when somebody's cranking. And because they're AC, they had a frequency. They had a frequency between 20 and 30 hertz, depending on which country. And basically they packaged it all together into a case or a housing. And as years went on, improvements went on, and things got better to make the field phones operate better. Okay, parts and components of a field phone. You have a microphone. Basically, there are two types of microphones. There's a sound-powered microphone and a DC-powered microphone. The sound-powered microphones are interesting because they have no batteries in the system. They're just basically use the actual electrical energy delivered by the microphone to send it to the other end. You don't see them used a whole lot anymore in field phones. They are used in naval and maritime industries and in mining and places where you have hazardous atmospheres where you don't want sparks. Most of them nowadays use a DC-powered microphone. They apply a small voltage and amperage to the microphone, which actually improves how well it changes the sound electricity and sends it on down the line. Then on the other end of the handset, you have your speaker, which changes that energy into sound again. Most field phones have a handset. A lot of them have jacks or plugs you can add an extra handset or headphone or something so someone else can actually listen in or participate in the phone call. You have incoming call ringer, usually a bell or a buzzer that when the other end sends the higher voltage ring signal, it causes this to go off for light. The newer phones actually have electronic beepers in them. Of course, you have the ring generator, which usually is a hand crank magneto, which you crank on, or some of the newer phones actually use an electronic generator. You push a button and it generates the ring signal. You have a wire connection point binding post. Some are spring loaded. You push it down and put the wire in the jaws. Other ones you have to unscrew and either push the wire through the hole in the side of the terminal, tighten it up, or actually wrap the wire around the terminal. Then that all ends in a case or housing. A lot of them use metal. A lot of the European ones use Bakelite because it was available. And as the phones went forward, you had internal components to do filtering and line balancing, which just helps the phone work better. So this is basically all wrapped together into your field phone. Okay, now we're going to talk about modes of operation. This seems to be the most questions that I get asked and can be the most confusing thing. There's basically 3 different modes of operation. There's a local battery mode. The field is actually, or the phone is actually powered from local batteries, either internally or externally. These batteries basically power the microphone. In later models, they provide power to some of the indicators and buzzers and lights and transistor amplifiers in some of them. And most of the phones, when you set for local battery, you're setting it to operate as a point-to-point phone. That means you're talking to another phone at the distant end, or possibly a manual switchboard. And there's a little switch or screw on there that you can turn the switch to switch between the different modes. That's local battery mode of operation. The next mode of operation is the common battery mode, sometimes called CB or CBS. The field phone receives its operating power from the switchboard or telephone exchange it's connected to. This basically means you don't have to have batteries in the phone. You pick the phone up, it signals the switch and says, hey, I'm off hook, and gets power to operate. The switchboard operator then sees the little indication that you're off hook and answers and processes your call manually. Now, some of the phones have an additional common battery mode, or CBS it's called, which means you pick the phone up and you still use it like you normally would, except you have to squeeze the handset push to talk to make it work. Basically, common battery is how your home phone operates. There are also some of them that, in more advanced ones, you pick the phone up and it'll send you dial tone for some of the field phones that have dialing units built into it. One thing to remember is common battery will not work in point-to-point phones. What I mean, if you have 2 field phones connected together and you want to talk to each other, you can't run them in common battery. You have to run them in local battery mode. And you have to have a switchboard or an exchange will still send you a ring signal. So say you're running in common battery and you're connected to the switchboard. In order for the switchboard to call you and let you know you have an incoming phone call, they still have to send you a ringing voltage from the phone. So that's just how it operates. And that's his common battery mode. Okay, now we'll connect the phones together. Basically, the wiring connections to make 2 field phones work together. Basically, the wiring they used, actually solid bare wire to start with. And this was, if you see the old pictures of the telephone poles that have the cross members and have, all the wires strung out on insulators. That's the first way they ran them. Then they ran to, of course, a solid insulated, went to a stranded wire. Then when they discovered you needed to have 2 pairs or 2 wires a pair to make the field phones operate, they did a simple twist to hold the 2 wires together. They then also discovered that this twisted pair also reduced crosstalk between the different phone lines if you had several of them. They went with a solid twisted pair. Then they went to multi-pair cables that were either aerial or buried underground. A lot of the conductor materials basically started out simple and became, more exclusive and exotic as time went on. First they used iron, steel, and stainless steel wire. Then it was discovered copper worked really well. Silver worked real well, but it was expensive. Then later on into the 70s and 80s, they started using aluminum because it was so lightweight. You could make a spool of field wire that a soldier could carry that was hardly had any weight. Then they started going to alloys, where they started alloying the different metals together to make, the field wire. They'll basically run on anything. We've done demonstrations where I've actually run it on extension cords that weren't plugged in an outlet, but they were used between the phones. So you get an idea. You could use speaker wire or Cat5 or any of the commercially available field wires you can, or excuse me, telephone wires you can buy, or bell wire, garage door wire. So I mean, it's your imagination, and also depends on how far you got to go. Okay, now let's talk about hooking multiple field lines together using two-wire field wire. If you look at the top diagram, this is the correct method to connect parallel phones, whether you call them parallel or party line or platoon, hot loop, whatever. This is how you do it. Basically, you'll want to take and where you come out of the first phone, you'll go to the second phone, you'll twist the wires together, then stick them in the terminal, and just continue on down the line. This is done for two reasons. The first reason is when it's time to recover this wire, it's easier to go ahead and splice a spot where both wires were cut the same thing and roll them back on the reel and fix them and reuse them than it is to try to splice together where they cut chunks out to allow the hot looping like below. And the other thing is, if you look at below, if the one underneath the bad, if one of these phones in the middle has internal components fail, you're not going to be able to talk to anybody else down the line. Up above, that's not the case. This phone right here, the second phone in line, could have a failure inside, and you would still be able to talk to the other phones. Actually, all the other phones, the four phones in the middle, could die, and you could still talk to the end phone. That's the reason you don't want to do this. This is a bad thing to do, and I don't know why the Army teaches this. They used to teach it. In the Air Force, they told us, do not do this. I had a boss that threatened me one time. He said he'd kill me and wrap me up like a mummy in field wire if I ever went out and hot looped field wire like that. So this is it. This is a wrong way to do it and a right way. Next, we're going to talk about four-wire phones. These are phones similar to field phones, except each phone has two send wires and two receive wires. They operate in what's called full duplex mode, which means they can send and receive audio at the same time. These were built because it's easier to send separate audio streams than it is to have just two wires. And it's generally used for trunks. And what a trunk is a connection between two switchboards usually. The U.S. military's Audubon system in the 1960s, when they came out with it, the initial phase actually used four-wire dial-up phones like this. And the reason that was done is because they could give a base or a post, let's say, four Audubon four-wire lines and connect a phone to them, and they could make Audubon calls to a centrally located Audubon switch. But then when Phase 2 and Phase 3 came online, basically they converted these actual phone lines coming in to trunk lines, and then they connected to the base or post switch, and everybody could use to make Audubon calls. So that's why they originally came up with these. These phones can operate in a point-to-point mode, and they don't have a hand crank, so they actually use a tone. So when you pick the phone off hook, it sends a tone to the other phone, which rings, you know to answer it. There's no hand crank. The problem with these phones is they won't easily interface with two-wire phones, and you also have what's called the four-wire phone problems. They require twice as much wire, and only two phones can be connected at the same time. The most common four-wire phones you'll see, I've seen them on eBay and other places, is a TA341, the gray phone, and a TA838. The TA341 is a lot less expensive than a TA838 is, because the 838 has some other features that it uses. But they'll both talk to each other. They're both good four-wire phones, and they're fairly rugged. So if that's the avenue you need to go, you can go ahead and get a TA341 and a TA838, or one of each like I have. The way you connect four-wire phones is you have to do a crossover, as it shows here in the diagram. So from phone 1, you want to go from the send binding post to the receive binding post on phone 2, and then vice versa. I mean, this crossover has to be done or the phones won't work. This is one of the reasons it prevents you from paralleling or doing a party line with four-wire phones, is this setup right here. So like I said, this is one of the four-wire phone problems. Okay, now we're going to talk about digital non-secure voice terminals, or DNVTs. You see these out there in different places, and they are usable if you get the right phones. They're basically a digital four-wire phone that can be used in either a point-to-point connection to another phone, or if you have a digital switchboard, you can connect them up and they can do dial phone calls. They operate in either local battery or common battery modes. When you're operating a local battery, you have to have an external battery connected to it, but there's a point that shows you where to hook it up at. They often have interface points on them or ports on them where you connect other equipment such as fax or computers. They have a selectable data rate, usually 16 or 32 kilobits. They will not work with 2-wire or 4-wire analog phones. I don't want to stress this over and over again. They will not work. And like the other 4-wire phones we talked about, they cannot be paralleled to create multi-phone line drops. Okay, these are the only two DNVTs that you can buy online or different places, eBays, that will actually work with each other. Is a TA1042 or a CA67. If you see TA954s or 1035s, don't purchase those because they won't work with each other in a point-to-point configuration. A 1042 will talk to another 1042 set in point-to-point mode, and a CA67 will talk to another CA67 set in point-to-point mode. So just remember that. These are fairly good phones for this. A little bit more expensive than what you may want to pay for a phone. I've seen TA1042 sell for $100 a piece. Higher sometimes. Same for the CA67. If you want some, the best thing to do is just keep your eyes on what's going on. And like I said, pick up two phones. You got to have two phones for these to work. Okay, and for the final thing, we'll talk about how to wire DNVT phones together. They connect just like the 4-wire analog phones I talked about earlier. You have to connect the send terminal to the receive terminal from DNVT1 to DNV2 and vice versa. And you've got to have that crossover. And just like the other 4-wire phones, this prevents them from being able to set up parallel phones or party lines with DNVTs. Thank you for watching.